Hi, welcome to part 2 in Algos and 10. This time we start with a very awesome tree data structure called the AA tree and make a very interesting application of it with the Family Guy characters of Peter Griffin, Glenn Quagmire, Joe Johnson, and of course Cleveland Brown. I don't watch Family Guy that much, guys, just a disclaimer, I'm more of a Simpsons fan, so yeah, though. But it's nice to see how like we got to use the Family Guy episode when they infiltrated somebody's palace. I'm not gonna say who, but somebody's palace with the AA tree. So let's get the party started with Algos in 10 part 2 with the AA tree. Hashtag split and skew. And to prove I'm not much of a Family Guy person, I actually should have known this was Joe Swanson, not Joe Johnson. Sorry about that. Anyways, make sure to subscribe to the channel. As you can see, I made a very sweet looking AA tree with the subscribe, left subtree, right subtree. And you can see on the left, there's a split operation, and on the right, there's a skew operation. Hashtag AA tree, and we're also going to use the post-order, pre-order, and in-order traversal of the tree. I'll do a very quick tree review and AA tree operations before we get to the problem set. So to begin the Algos in 10 part 2, we have to ask ourselves, what is a tree? So when you think of a tree, you think of a tree like this, right? Like a good old, beautiful looking tree. And in any tree, you got something called the root. And you also got something called the leaves. This is like really first grade biology, but that's how computer science thinks about stuff. So next time you see the professor wearing an upside down tree and some sort of swag shirts, or if you work for like a co-op or a company that actually specializes in AA tree, make sure you understand this data structure really well. So in general, there are 3 types of main trees that people should very well know when doing leak code or doing any type of tree problem. Our quintessential AA tree, the binary search tree, BST, and of course, not to get racist with tree colors, but the red and black tree. We're going to only cover the AA tree in Algos in 10 because the BST is something you can just simply look up online, and red and black is not covered that much at Northeastern. So yeah, that's the AA tree general structure. With any tree, you start off with a node called a root. And then you have something called the left subtree and the right subtree, which you can pretty much tell what the tree is trying to do, right? You're trying to basically do something that's very similar to binary search. If you don't remember the charger real smooth by now, you should probably review Algos in 10 episode 1 before you continue this. But anyways, you basically do something called a binary split of between the nodes in the trees. So now I'm going to show you guys very quickly how to do the traversals of the trees with my favorite numbers 1 through 6. And also to show you why split and skew works for the AA tree in general. This is a lot of setup for a problem, but this is a trickier tree problem than the per usual binary search tree, count the children, or count the cousins, or count the ancestors. So in any tree traversal, we have the pre-order, post-order, in-order, which is the left of the root, right of the root, and center of the root. So let's say, for example, we have a very simple tree, like 3, 2, 1, and 4. All right, so pause this video and give it your best shot what could be the pre-order, post-order, and in-order. I want to see a little more audience in the Algos in 10 now. Post in the comments below if you want to know what your solution is. That's been long enough of a pause now, so let me show you the solution. For the pre-order, we go from the left, right? So we start from here. So you go from 3 to 2 to 1, then to 4. That's the pre-order traversal. Post-order traversal is the other way around, it's from the right. So you go from 3 to 4, to 2 to 1. And then finally, in-order traversal is the most interesting. You start from the middle of the tree. So you always start from the root, 3. But then you have to go from the middle of each node, which is actually very interesting. So you go from 3, you can either choose 2 or 4, but obviously choose 4 because that's the next empty root. So choose 4, then go all the way back up and go down to 1, and then finally to 2. Definitely double check your work with tree traversals because many people get these wrong in LeetCode right away. Now let me show you the split and skew operation of the AA tree. I'll have the AA tree in Wikipedia link as reference. So we're going to try now some AA tree split and skew. So let me come up with a lucky number 7 to start off this thing. And then let's choose a number right below it, 6. And then choose another number right below it, 5. Uh-oh, we already violated the problem. We already have a violation of AA tree. That you cannot have 2 or more grandchildren under root. I'll just say GR under root. That is not allowed, as my professor would say. So you do the good old split function, which means you rotate to the left and you also increase level by 1. So the split operation for this tree would then just be good old 6, 7, 5. If you want to do the skew operation, let's say we add in now 4, right? Add in now 4. That once again will push everything up and it will lead to 4, 5, 6, and 7. That's your skew. We'll push everything to the right. And you decrease by 1, the root. Hopefully you'll see why split and skew is very important once we actually get to the problem set. But if you do not understand split and skew, I would highly suggest trying a few examples on paper or on the whiteboard or whatever you want. It's a very interesting operation in the AA tree. So here is the problem statement now. You have Peter, Glenn Quagmire, Cleveland, and Joe, the AA team. Why we call it the little bit of a joke of a day. We don't call it the AA tree because of the AA team, but that is a Family Guy reference. So from this, they infiltrate somebody's palace, which is shaped like a tree. For example, they have this type of palace. This is a very good looking AA tree. So let's just say, for example, Peter starts from this beginning. Cleveland chooses the middle. Quagmire, giggity, chooses the left. And a good old Joe chooses the right. So that means Cleveland goes in order traversal. You gotta see why I now mentioned the traversals, right? Joe goes the post order traversal. And then Quagmire, of course, goes to pre-order traversal. Here's the catch though. You can't always assume these positions. This is why the problem gets tough now. So we'll go right again to what we have always used in Algos Intent -1 episode, divide and conquer. But this time we're going to jazz it up a bit and call it structural divide and conquer. Yes, that is an actual thing. Structural, which means with the tree, divide and conquer. So to do a little prep work, we'll need to do the following. We'll need to define something called a tree node, which has the following parameters. I'm using Python pseudocode for this. Using the word self, which means a self-defined function. Then you got the left. Then you got the right. And this will be basically our node class. And of course, in each of a node, you got a value to determine the value of the tree. I'm not going to use pseudocode for the solution, but this is like generally how you want to think about if you do this for a code interview. Now let me go through the divide and conquer steps of this beautiful problem set, where Peter, Quagmire, Cleveland, and Joe try to infiltrate somebody's palace using AA tree. You can see I'm making a very unusual divide and conquer, almost like halves, because you'll see why. So the divide is pretty simple. We just take our AA tree, which I'm going to redraw conveniently over here, and we're going to do a little bit of a split. So think of it as basically like a boundary between the tree. So dot, 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 we do a split. And then once we split between the tree, we do the following. Each time Peter, who is at the root, moves to the left, we call split and skew, which I hope you remember what that was, right? Split and skew operations. on the tree. There we go. That is your divide step. Just split the tree in two like a piece of chocolate cake and stuff it in your mouth. By the way, it is my birthday on Thursday, so I'm actually down to do that. Hopefully people are doing well during these times, because it's not very easy to be quote-unquote celebratory given what's been going in the world. So this is like a nice little distraction from that. So now we've conquered 3 main cases. Case number 1. If we only have Joe and Quagmire not move anywhere, so they're static. And Cleveland moving. So Cleveland is traversing. So Cleveland is moving, Joe and Quagmire not moving. Then we just call the good old post-order traversal, because as you could tell, there's only one way for Cleveland to go from the tree. And like as a visual example, let's just say we just had a really quick drawing. So let's just say Peter is here, Joe is here, Quagmire is here, Cleveland is here. If Cleveland goes left, he's going to end up hitting Joe. If Cleveland goes right, he'll end up getting giggity with Quagmire. So the only place he can go is post-order, which is right. Number 2, I'm not going to draw diagrams anymore because I want people to really get the flavor of the problem. If we only have Joe and Cleveland not move anywhere, but instead Quagmire moving, then we call the in-order traversal, which of course is very, very obvious as reasons stated below. And finally, for number 3, we pretty much can tell what's going on. If we have Quagmire or Cleveland not moving, and that Joe moves, then we're gonna call the pre-order traversal. So you're wondering, Jason, this is like basically asking me to put 3 different people in one room and hope they become best friends, or like a very awkward icebreaker. How do I put them together? Well, let me tell you. You put them together in a good old combine and merge step in a very special way. You guys need to go back to the clam for some beer and celebratory basketball, which Celtics and Heat play tonight. So let's finally wrap it up with combine and merge. So we have the 3 operations: post-order, in-order, and pre-order. And I'm not trying to do this on purpose, but they're not really in order. They're just simply 3 operations that the traversal does. And we also have split and skew. That's the operations we're given. So to do the combined step, we basically do the following. We call split on each left rotation of the tree. And then we find its value. So we do node.val equals whatever. Either it's going to be the value that Joe takes, Quagmire, or Cleveland takes. Notice that Peter does not move at all. Peter is still the root. You still keep Peter where Lois likes him, at the root, not drunken in the clam or doing other shenanigans in Family Guy. And then, of course, we call skew on each right rotation, which of course means, in this case, node.val is the inverse of whatever I had. So it's Cleveland, Quagmire, Joe. And to wrap it all up, eventually we will traverse the entire tree, or the palace in this case, because you have they basically traversed the entire AA tree. And there you go, that is your solution for this amazing AA tree application problem. Now real quick, I'm gonna show you the runtime. Okay, just like Peter arguing with Lois sometimes, this can get really, really repetitive and really, really like, what's a fire truck type of easy. So you have AA insert, right? AA tree insert, you got log in. AA tree delete, you got log in. Traversals, all of them for a tree is log in, because it's essentially just look up with the leaves. So in order, and also split and skew, each are just constant because you're just moving increasing and decreasing levels. To add up all the runtime, it's just good old log n, and that is your solution for the AA tree in terms of runtime. So now we're going to continue on part 2 with a very awesome Charlie and Chocolate Factory medians and medians problem. That one gets a little bit mathy, so I suggest reviewing median and medians before watching that video. Thank you very much. This is episode 6, Algos in 10 with Jason Liu, AA tree with Family Guy.